Okay.
This meeting is being recorded.
Okay. All right. So, like I was saying, so this is exactly the same thing as this. Like it's not just a wrapper around, and this one too is same as std. Sorry, sys dot. Okay. Okay. Or if you open a file, you can put your file here, and then that whatever you have will be converted to be written into that file. Okay. Okay. So this is how simple this is. All right. You can see we did not really handle the type error. Is there any to handle type error here? Yeah, if the type is coming from, so obviously in the way I've used this, right, type error will not even get the type error. In that case, yeah, we can still get a type error. So it's gonna yeah. So we can put a type error if you want. Separate them by comma. And now that I'm putting type error, so I want to be able to get the message so that I will know exactly which one is which, because I'm writing only one except. Normally you can write two except or more excepts function. So I just say as E. So as E, basically any output at all. So I can now say error and maybe put the E here so that anyone that happens, so that it will be printed out. Whatever, whether it's value or type error, to print out with one of this. Okay. So this one too, I can do that. It doesn't matter. It's not E. Okay. Yeah, so the thing here is that just to bring your thinking to a way you imagine your program or how you write your program and how you think about. Okay. What's happening is that you, Martins, can you please put off your mic? Okay, thank you. All right. So you can see, the way I've written. So it won't even make much sense for me to now start writing another question inside here. Okay, because I want to dedicate this particular one to this multiple. Okay. All right. So any question about this? So I'm going to see other things we've already mentioned as well. So that's why it's actually important for you to actually try to solve the problems. Okay, it's only when you try to solve the problems you need to learn some of these things and reinforce those things that I've talked about, because it's actually very, very important. Okay, the way you write your code. Okay, we don't have much time, but let's just look at this second one. Okay. Okay, so again, I'll come here. And of course, to be fair, this thing can still be, simplified further. Okay. Because this guy here throws some errors. Okay. So if it throws a similar error as this, then there will be no need to put the type error. Okay. I was going to throw the error, but don't worry about that for now. But just for you to really see how you write your code, you arrange your code in a very clean way, so that somebody working on your code can also make changes where necessary. Okay, with ease. Okay, so let's look at before we go. Let's just look at the number 2. So I'm going to say here touch R_1_2 P1. Okay, so I have that file here. All right. So another thing too, like you see, I don't need to comment. I don't need to say anything here. Like I don't need to start commenting. Oh, this is a remainder when. So that is way too much. Okay, I've put my stuff here. You only put a comment on something that is very, very confusing, like it's not very, very clear. Okay, but once I have described this, it has covered all the comment I need on this, so I don't put comment all over the place. Okay, especially when you want to store some code in the server. When you start pushing code in production, we try to limit the comments because we don't want to put, especially front end code. Okay, especially front end code. Okay, we try to remove as many comments. We remove print statement. We remove all those things when you push it to code production, because all those things are necessary. They make it harder for you to get, for a user to get the application code from the server, especially for the first time. That's what we call loading performance. Okay, but that's front end. So let's just go on to this. Okay, so write a short Python function is even that takes an integer value and returns true if k is false otherwise. Okay. However, your function cannot use the multiplication, modulo, and division operators. Okay. First of all, let's just write a doc. Type here to describe what this function is about. Okay, just something simple. Okay. Determines if a number is even. Sorry, determines whether a number is okay. A number is even or not. Okay, that's what it's about. It's about. Okay, so I'll just ignore the examples I'm going to give because this is obviously simple. Like a number is even 4, 2, 3. So those ones are simple. Like 4 is even, 6 is even, 3 is odd. Okay, so it should return. So now I'll just say it's even. Okay. Again, I'll do pass. And I'll go and write my main part of the function. So the usage. So it's always important for you to know how you program. That will direct, or that will inform the way you write your code, so that you have that in mind. That is why most of the time we prefer test-driven development, so that you write exactly. It forces you to write the correct code. Okay, you want to pass, but sometimes you can also. But the bad thing about it actually, because the disadvantage also, sometimes you can write the wrong test and you try to force your code to pass the wrong test, and then that will also be a problem. Okay, it happens a lot too. Yeah, but if the writing out the way the usage of the function will actually help you to even have a better understanding of the function. Okay, all right, so that's why it's important. So it's even. All right, so I'll say so let me just write directly try. So I'll get the number. I want to get the number as the user is running the code as well. So I'll just get the number. So what I'll say is try underscore n equals, again, since I have I need to use 6 import 6. Okay. So I'll say int 6 dot. So this is just one argument, so I don't do that one. Okay. Then except. So what can we throw here? What do you think? So the value will have to be not type in this case. Okay. Value error. Okay, because the type can be string, which is going to be string anyway, but string numeric. Okay, so I just say value. So let me just use this as E. So again, I do standard system.stdr.write. Okay, whatever error, just say error. Just make it. For C, I'm handling it, so just do whatever message that gives me. That's fine. Okay, so again, 6.standard output this one, because it's not error I'm printing. Yeah. So even if you use this in your program, right? Even if you use this in your program to try to print out, it will not print. To try to show something on the screen, unless the thing is error. That's the thing. So you force it to only print out error. Okay, only work when there's an error in the code. Okay, so here again it's even. Sorry, it's even here as the value n. So this will return true or false. Okay, so I'm not going to go through the writing the doctrine all that, because obviously I'm not writing production for all of that, but it's for you to really understand this, and in most contexts you have to use it. Okay, but again, this is also kind of self-explanatory. So I mean, I can still add one or two things, but it's okay. I'm not going to worry about that. Okay. Now this exception here is it's because of this that is throwing. It's not because of this function. Okay. Because once this is passed, it's not because of this function. So if I want to write for the function, I will still have to write it here. Say if not instance. I'll show you guys what I've got used to this now. Okay, it's not an int. I want to raise. So just basically you're just raising an alarm that this is invalid. Okay, must be an integer. Okay. So yeah, so now the challenge here is how. So you have they say you should not use. Normally, this would have just been as simple as saying k these 2 rad 0, and that's all. Okay, but it says you shouldn't use modulo. You shouldn't use any of that. So there are other operators on integer. Okay, there are other operators apart from these other ones. Okay, that's what there are what they call it the binary operators on integer, or binary operations on integer. So whenever they tell you something like this, okay, just know that they want you to use the other operations on integer, which are binary. Okay, I'm sure we've not used binary operations on integer. Okay, let's take a look at how do we know that. Let's look at these binary numbers. 4 is what? 100. Yeah. Oh, 100, not 100 actually. 2 is what? 10, right? This binary. 1 is of course 1. And so first of all, do you understand why 2 is why this is it? Is this 4 is 100?
Isn't that the binary representation?
Yeah, binary representation. Yeah. Okay. So, and yeah, just for you to maybe just to remind you, there are different ways you can get this, but 2, this is 2 raised to the power 2. Okay. Sorry, 2 raised to the power 2, like that. Okay. So
that's 2 as binary base 2 now. 4 divided by 2 divided by 2.
Yeah. Okay. Yeah. So the remainder, and then so you can get that. But another way to quickly just get it, that you can express it as what do we call that thing in primary school? Is it multiples, right? Where you do, or factors? So yeah, factors of 2. Okay. So every factor of 2, right? That one, every factor of 2 will have the power. So the power would represent the number of 0, because 4 is 2 raised to the power 0. So sorry, 2 raised to the power 2. That's why we have 1, 2 zeros. So what do you think 8 would be? 8 is 2 raised to the power 3. That's why I have 3 zeros. It's 8. Okay. And let's say 16 would be what? 4 zeros, and so on and so forth. Okay. Now, but the thing here is that every, let me see, I think 6 is this plus this plus this 6, right? So 6 would be 1, 1, 0. Okay. So every even number will actually have this as 0, the last or the least. Is it the least or the it the least significant bit? What do you go? You people that know maths, please. Is this one the least significant bit or the most significant bit? Okay, it's the least. Okay, every odd number will always have one as like 5, for instance. It's 5 with 0, 1, 0, 1. Okay, always end with 1. Odd numbers end with 1. 3 is 1, 1. Okay. This is just a short stuff about binary number. So it just, every odd number will end with 1 and every even number will end with 0. Okay. So that's just what you need to use to solve this problem. So the idea, so you just need to know, how do I get the least significant bit? Okay. How do I get the least significant bit? All right. And how do I know? Okay, not even get now. How do I know? How do I identify the least significant bit, the number, whether it's a 1 or 0? You know, a binary number is always 1 or 0. Okay. How do I look at a number and know whether the least significant bit is 1 or 0? So whenever you apply a binary operation on a number, right? So one of the binary operation, the OR is this one. Okay. This is a binary operation 1. This is OR. This is AND in Python and most languages actually. This is AND. Okay. So when I do this, I'm saying K or 2. That's binary OR. Okay. And if I have something like this, 1, 0, or because let's not confuse this one. So it's this one. So if you put that one, it won't be binary operator. So or okay. First of all, X, let's look at X and Y. Okay. So when you have X or Y, what will be the answer? And what condition? Do you remember? So it's, you know, it gives you true or false. Okay, if this is true, what does that mean? If this is true, what does that mean? I have two numbers, X and Y, and I say X or Y, binary Y, or so, and then it's true. That means that at least one of them is true. So 1 or 1 is what? We'll give you what? 1. Yeah, 1 and 0 will give you what? 0. This binary operation, but it's not this and. Just take note, it's not this one. Okay, we're not making it explicit here. Okay, and yeah, that's basically all you need. You need to know these two. If you want to know these two, you are good to go to solve this problem. Okay, and okay, you need that 0 and 0 will give you what? 0. 1 and 1 will give you what? 1. So this binary OR is true if at least one of them is true. At least one is true. Okay, so that's why if I have 1 or 0, give me 1. So these ones are mean true. This one means I'm just using it to be true. Okay, to give you. So if I combine 1 and 0, to give you 0, 0 and 0 give you 0, 1 and 1 give you 1, 1 or 0 will give you 1, 0 or 1 give you 1. Okay. So what we need to do now, so the trick now is to be able to try to do a binary operator on the least significant figure, on the least significant digits of any number. Okay, so I want to do, all I just need to do is to check this number. That's why when you're performing, if you want your program to be fast, use binary operator, like the fastest of the fast, like it's going to be is the most. If you want it to be very, very fast, you use binary operators like where possible. Okay, and most of the time we use that in our code as well when speed is of consigns or break consigns. Okay, so the idea is that it works faster because all these other ones now, there are a lot of things that are written on top that will make it. This goes directly to the hardware or to the machine language and perform the operation without passing any intermediate step. So it's always very, very fast. And that's why when you're programming embedded systems, right? Systems programming, right? You will use a lot of binary operators or operations. Okay, because you want that to be fast. You don't want somebody to click on, you don't want the pilot to press a button on the plane and then the thing will be wasting some time before the plane will respond. Okay, so when you're writing anything that has to do with hardware programming, we make use of this heavily. Okay, because it's fast. Okay, so now the idea here is that I need to just look at the number and get the least significant digits, and then AND it with 1, because just 1. All right. So here, if I just say 1, okay, K is a number, or no, it's not or. This is AND. Okay. So this 1. So whenever you have 1 like this and try to AND it with, for instance, like this, what actually happens is that the computer will always make sure that the computer will always make sure that they have the same number of digits, so you put 0 in front. Okay, so that's why this one we AND with this other one. So if you want to AND this with 1 like this and 1, what actually in reality is that your computer will fill in the gaps like this, so that this last one we AND with this one. Okay, so that's why this is the solution to the problem. Because any number here, because is this what happened that one computer, when Python encounters this, it converts this to a binary and does that operation. So when you can encounter a binary operation, so it converts the number, both of them combine into binary. So and then it will now have the same number of digits. So let's say we have 8. So 8 will become this, and the 1 will become this, and then because all of this will give 0, 0, 0, and 0 is 0. 0 and 0 is 0. So the last one now, 0 and 1 is 0. So if it's 0, then that's even. Okay. If imagine, like, look at this one now. I have, will now give me 0, 0, 1. Okay. While all of this will be 0, this one will now result in 1. The last one, sorry, the last one here. This will be 0, 0 and 0 is 0, 0, 0 is 0. Then 1 and 1 will give you 1. So the answer will be 1 here, so which give me false. Okay, so that is when you don't want to use any of those binary, you don't want to use any of these operators, so you use binary, just resolve the binary, and this works for integers. Okay, so that is it for the problem. So you can see that the problem is being solved here. Okay, by just, that's what it means here. All right, so yeah, so let's try it out and see. What we do, type, okay, let me save it first, not saved. Python R12, and then I'm going to pass a value. Let me start 4 true. Okay, let me do 7, should give you false. 9 should give you false. Okay, then 12 should give you true. So you see, this is how you can do solve the problem. So any question? Yeah, you can see it's taking us a lot of time to just explain this, which is, it's important that we explain all of this. All right. So again, always try to put, yeah, but later on we're going to see why we also do this, because this normally this is where we now put our unit. Like if you're writing Python package, you want other people to use, this is where you put your unit test. You will still be shipping it with this. But the good thing is that because you're putting it inside this if statement, it's not going to be executed when somebody tries to import it. So the code will not run. The code will only run when you're running as a script. Okay, in this case, and try to run your code as script and get used to this. It's very important you get used to this guy here using the system to get it from there. So you see all this input, enter input, this, you hardly use them going forward. Okay. So even if I want to use input here, I don't, it's just for, maybe I want to check something. I just say, okay, maybe here I can just say X equals input. I don't necessarily have to start writing all of those things inside the input. Or maybe use int here. So these two things actually they do the same thing. Okay. Okay, but of course this one waits for you to type. And then the one that, okay, let's see, there's another one here which I have not mentioned. sys.stdin. Okay, dot read. Okay, this is the same thing as that input. Okay, but you know the difference now is that here you don't have to put, you can't put, it won't work. Okay, all right. So this one now, anything you put here, it will read that number of bytes or digits. Okay, so yeah, you can check that out. It's also faster than this other one. So if you're thinking of using something that's fast, this you go with this system. That's why most production code we use that a lot. So any question? Any question? Any?
So I thought that you're going to explain the binary concept where you have which one, because I didn't quite get what you're explaining. Where I know that you're trying to explain that in the system trying to print the last number, identify the last number, but I wasn't so clear.
Okay, the last
when you
digit,
were-
the most least significant, the most,
Yes,
no,
yes.
that's the least significant digit of
Yes.
binary. Okay. So yeah, so whenever your program encounters operation between the two operands like this, right? It converts them. It becomes very, very happy because that's what it knows. So it converts them to binary numbers. Okay. So let's say it sees you give 8 here, as to give, maybe put 8 here and you go to 8. Okay. 8. So, and because the next number, the next operator is this binary operator. So what you do is that you convert it to this. And then now make sure that the next thing that comes here has the same number of digits. Okay. Now let's say we have like 16, 8 and 16. Okay, like 16 here. Okay. What will happen then is that this will be 4 zeros, and then a 0 will be added here. Okay, to always make sure that they are two. So when you're adding it doesn't one by one. So corresponding to take this one and with this. Okay. So the answer to this one will be what? Just 0, 0, 0, because yeah, because 0 and 1 is 0, 1 and 0 is 0, and 0 and 0 is 0. Okay. Yeah. Now, why we put 1 here is that because we are only interested in the last digits. Okay, the least significant digits. So all this other one, they definitely give 0. It doesn't matter. Whatever you add with 0, it is 0. All right. Whatever you add with 0 is 0. Okay. But the last one now here is what now determines. So if I add this one with this, sorry, it's a lot. So when I add this one and this one, they give me 0. Okay. And that shows that that is what? One of them is 0, which means the number has the least significant digit of the number is 0. When the least significant digit of a number is 0, means that that number is stable. Okay.
True.
Yeah, that number is 1. And if the least significant, and if you want to try it, it just basically, this is how it goes now. Remember your division in primary school, where say for let's just assume that is definition. Yeah, sorry, 2, like this 4, right? So this will give you 2 remainder. Remainder what?
Remainder 0.
Okay, and then 2 will give you
No,
sorry, it will give there's a way to do it. There's a way to do it. I can't really draw it here, but there's a way to do it where you have 2, 4.
2 under 4.
Okay, yes, sorry. Yeah,
and then put arrow 0.
2, and then okay,
0.
So this one arrow 0. Thank you. Then I put 2 here again.
1 arrow 0.
Arrow 0.
Then 0 arrow 1.
Then we have 0 remainder 1. Then you now count from the bottom.
Oh.
I don't remember the way they used to explain this in there. Those days.
Forgive.
That come from. That's why we don't use to understand this is very well. The way they used to explain it. Anyway, yeah. Okay, so you now count from here to here and get that. Okay, that's basically how this is done. Yeah, that's why you have this one to always give you 0, because when you divide 2 for the first time, it is to give you 0. That's why it's 0. Okay, that's why it's always end with 0. So if I change it to 5 now, it means that when I divide for the first time, give me a remainder of 1. Okay, so this one will now be 1, and then this is 0 and then 1. Okay, so that's just the basic idea here. So you are trying to perform an AND operation on the least significant figure. So that's why you use 1 here. Okay, because 1 will determine whether it's 0 or whether the least significant figure digit is 0 or 1. Okay, because if you AND 1 and 1 to give you 1, it means that that's what the least significant figure digit, sorry, of that number is 1, which means that number is odd. So if it's 0, yeah, so that does the trick. And like I told you, it's very, very fast. Systems engineering, when you're doing systems programming, microprocessor programming, we use that a lot. And one of the things about embedded system too, the memory is not usually big. So we try to conserve memory by using things like just making things fast and all that. So the thinking, which we have been, all the programming you've been doing application programming. The thinking around application programming is a bit different from systems programming. Okay, embedded system programming. And that's why we also mostly use language like C++ or C++. You're always thinking about memory. You don't just declare variables anyhow and then leave them anyhow. But I mean, that's not what we're doing. So we're doing application programming. So yeah, so all those things have been taken care of under the hood. Yeah, so that's it. Any more questions? I think we have about 5 minutes. 5 minutes. Well, yeah, just try this thing. We're not going to go back to it again, but just try it. I'm not giving you,
Mike, you shared this book with us, right, in one of the emails?
Yeah, I did. Not email. I think I shared on the group or email. I don't know. Like I shared it. You guys have. Okay, it's always a good idea to try this question because that's the only way you really learn. Okay, otherwise you can learn all the theory in programming, learn, not really. But when you sit down and start writing code and start trying them out, you will be able to do this. But the problems are quite simple. They're not really okay. But just
so
to you. Sorry.
So what's the plan? Is the plan to cover the chapters in this book?
Yeah, that's actually the plan. Okay, that's actually the plan. Okay, so to make it clear, yeah, just to cover the chapter. We have done with chapter 1, though, but we need to quickly jump onto chapter 2. Maybe a nice class.
Nice.
Yeah, then we do. There's a lot here, but it's important that we know these things so that when we're writing the algorithm and data structure, because the algorithms are usually in the classes, we're going to use classes to represent the data structures. Okay, like this is a data structure called vector, for instance. You can see all this. Okay, so it's not when we are doing algorithm and data structure, we start learning what is set item, what is get item, what is len, add, this. Okay, these are some standard stuff in Python classes that we always use. So we need to get used to them, okay, before we now start. The main thing starts chapter 3 here, algorithm analysis. So now you now begin to think about your code in a certain way, in a more advanced way. You look at your code and begin to classify it. Sometimes when you classify a code, you can classify your code to be linear or n log n and quadratic. So I think we have other ones too. Cubic or polynomial. And by the time you write some code, you just realize that no, this code is a quadratic, it's of order, it's a quadratic order, so you need to change it to n log n or linear to make it faster. And these are the kind of thing they will ask you in an interview, like when you've written the code, maybe you've gotten the answer right, they will not tell you, okay, can you make it faster? So you first of all be able to identify what classes of solution do you have, what class of solution do you have with you, and then you now begin to see how you can move it from. Usually, in fact, some of the scientific discovery, some of the technological discovery, and all of most of the things that you just being able to move. We're going to show you some example. Being able to write some code and move it from this class to this class can lead to a technological breakthrough. Okay. That's why something like CD-ROM came from that kind of thing. Being able to
CD-ROM.
Yeah. That's why I
came okay. Conversion of
conversion, yeah, yes, it's conversion stuff, yeah.
Okay.
All this conversion from MP3 to this to that. It's not because of people they've written solutions. Some of the programs have been written for a long time, but nobody will be able to move it from here to there. To move from there to there, then a whole new thing will come out.
Okay, nice.
Yeah.
That's a new one, yeah.
Yeah. So we're going to, from next week, we're going to meet in the morning. I believe that time will be better for everyone. All right. Hopefully, Peter Obi wins the election. Then,
my brother, hopefully, I hope you're also voting.
And I'm supported. I'm giving moral support.
Before they come stain your white.
I'm giving moral support too.
I hope the man wins. So people they don't want
the man
vote
by doing that.
Sorry.
I've lost one vote by giving only moral support.
No, don't worry. I mean, I know that they will rig the election and they will announce the that one is not even. There's no argument about that. They'll rig it. And
let's see how it's going. So if you must win